This is Module 8, Section 3.1. In this module, we're going to look at rectangular coordinate systems, ordered pairs, plotting ordered pairs, and completing ordered pair solutions. The rectangular coordinate system, or the Cartesian coordinate system, is the system we're going to use to plot our solution sets, two variables. In Module 7, we discussed graphing solution sets on a number line for one variable relationships. The number line graph was a visual representation of all possible values of our single variable. However, in this section, we are looking at solutions for two variables instead of just one variable. With solutions that represent values of two variables, we need two number lines. The rectangular coordinate system is built from these two number lines oriented at a 90-degree angle, which means they're perpendicular to one another. And the horizontal number line, called an axis, represents one of the two variables. The vertical axis, the other variable. The two lines meet at 0 for both number lines, and this intersection point is called the origin. For discussion, we will define our horizontal axis as x. So over here, we've got our horizontal number line. We're going to let that be our x-axis. And our vertical axis as representing our y values. So we have our x-axis running left to right and our y-axis running up and down. Notice that the axes cut the plane that they are into. And a plane is just like a piece of paper. It's a two-dimensional shape that goes on to infinity in all directions. The axes cut the plane they are on into four regions called quadrants. These quadrants are labeled with Roman numerals and start in the upper right quadrant, then continuing in a counterclockwise direction. Okay, so if we look at the rectangular coordinate system up here to the right, again, notice that these axes, the x and y axes, cut our plane into four sections. There's one here, one here, one here, and one here. We're going to number them with Roman numerals starting in the upper right-hand corner. So up here in the upper right-hand corner, this is referred to as quadrant 1. And then you are going to number in counterclockwise direction, which is opposite of what you probably instinctively feel you should. Going in counterclockwise direction, then up in the upper left, you've got quadrant 2. Lower left, quadrant 3. Lower right, quadrant 4. Any points plotted on the rectangular axis that lie directly on an axis are said to not be in any quadrant. That is, points on an axis have no quadrant designation. Okay. When you have two numbers to describe a solution, in other words, a solution for x and a solution for y, and you are wanting to graph that solution, an ordered pair is used to define that point on the graph. So you've got parentheses and you've got your x and your y. Order is important. The x value or x coordinate is written first, and the y value or y coordinate is written second as you look at it left to right. For example, if you have the ordered pair 3, 4, what that means in terms of solution is that x is equal to 3 and y is equal to 4 for that particular relationship. Negative 5, 1/2 means x is negative 5 and y is equal to 1/2. 0, 0 means x equals 0 and y equals 0. And remember, the two number lines on the rectangular coordinate system meet at 0 for both the x-axis and the y-axis. And so that's referred to as the origin. So, how do you plot a point on a graph? There is more than one method, one of which we're going to demonstrate on the next slide. There is a typo here. That should say one of which is demonstrated on the next slide. Okay, here's our steps, and then we're going to do some examples. To plot a point on a rectangular or a Cartesian coordinate system, you want to start at the origin where x is 0 and y is 0. Your next step is to look at the x value first and move the absolute value of x units. Now what that means is you're going to look at the x value and just look at the number first. Don't worry about whether it's, say, a positive 5 or a negative 5. Once you figure out how many units you're going to move, okay, then you'll move right if x was originally positive, and you'll move left if x was originally negative. From that point, so you're now either somewhere to the right of 0 or somewhere to the left of 0 on the x-axis. From this point, look at the y value and move the absolute value of y units. So again, ignore the sign for a minute. Just figure out what the number is without sign. You're going to move up if y is positive, and you're going to move down if y is negative. Then your final step, because you're now where that point should go, you're going to plot that point with a closed dot. So let's do an example. I have a Cartesian coordinate system written on the right-hand side. Again, for our purposes, we will always assume that the horizontal axis is x and our vertical axis is y. We want to plot the following ordered pairs on the coordinate system to the right and state what quadrant they lie in. All right, the method that we discussed is this. Always start at the origin at 0, 0. Switch colors here. Start at 0, 0. And move the x values first. So if you look at that first example, 4, 3, in 4, 3, remember that the x value is always written first and the y value is always written second. So start with the x value. X is equal to a positive 4. What that means in terms of movement is you're going to move 4 units to the right. You know it's 4 because the absolute value of 4 is 4. You know you're going to move right because positive x means right and negative x means left. So if we move 4 to the right from 0, 0, we're going to go 1, 2, 3, 4. That puts us right here. Then our next step is we're going to look at our y values. In this case, y equals 3. That means we're going to move 3 units for sure. Now the question is, do we move up or down? Since it's a positive 3, positive y values are up. So we're going to move 3 units up from where we stopped on our x-axis. So on our x-axis, we ended up right here. So from here, we're going to move 3 up. 1, 2, 3. There's our point. And we've got a label of 4, 3. 4 units to the right, 3 units up. All right? So let's look at our next example, 0, 5. Okay? Starting at the origin, okay? We're going to move 0 left or right and 5 down. 0 left or right, which means I don't move, and 5 down would be 1, 2, 3, 4, 5. This would be 0, negative 5. Okay, let's plot negative 2, 2. Okay, starting at the origin. Okay, starting at the origin, we want to go 2 units to the left because it's negative, 2 units to the left, and 2 units up because it's a positive 2y, 2 units up. There's our point right there, negative 2, 2. Okay, let's switch to black. Now we want to go negative 3, 1. Again, negative 3x means in terms of movement from 0, 0, we're going to go 3 units to the left because it's negative. A positive 1y implies we're going to move 1 unit either up or down. We're going to move up because it's positive. So always start at the origin. We're going to move 3 left, 1, 2, 3, and we're going to move 1 up. That value right there is negative 3, 1. 2, negative 4. All right, we're going to start at the origin. A positive 2x means 2 to the right. A negative 4y means 4 down. 1, 2, 3, 4. And we end up right here, 2, negative 4. And finally, we want to go 9, 0. Right, 9, 0 would be from the origin 9 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. And 0 up or down leaves us right on that x-axis. We've got here 9, 0. Now the second part of this question asked us to identify what quadrant each of those points were in. Remember, quadrants, if you start in the upper right-hand corner, number counterclockwise. So we've got quadrant 1 up in the upper right, quadrant 2 is in the upper left, quadrant 3 is lower left, and quadrant 4 is in the lower right. Okay, starting with 4, 3. 4, 3, you'll notice, is over there in the upper right. It's quadrant 1. 0, negative 5, which is right here, is actually on an axis. Okay? If your point ends up either being on the x-axis or the y-axis, it's said to be in no quadrant, so we'll just write none. Negative 2, 2, which was 2 to the left and 2 up, ended up putting us right there. That's in quadrant 2. Negative 3, 1, which was 3 to the left and 1 up, okay, right here, also quadrant 2. 2, negative 4, that was 2 to the right and 4 down. That was right here. That's in quadrant 4. And finally, 9, 0, that's that blue dot out here on the x-axis. Since that's on an axis, it's considered to not be in any quadrant, and so the quadrant designation is none. We are not in a quadrant when we're on an axis. All right, so what if the ordered pairs aren't given to you, like I just gave them? We have to know how to complete ordered pair solutions. So we talked about ordered pairs representing a relationship between x and y. In algebra, this general relationship is usually expressed as an equation or an inequality containing two variables. Just as discussed in Module 6, if the values for x and y make an equation or an inequality true, then those numbers are a solution of the equation or the inequality. For example, the ordered pair 2, 4 is a solution to the equation x plus y equals 6, because if x equals 2 and y equals 4, then 2 plus 4 equals 6. Both those sides are the same. That gives you a true statement. So let's do an example. Let's say you're asked, are the following ordered pairs solutions to the equations below? What they're really asking you, therefore, is if you put those values in for x and y, do you get a true statement in that equation? So let's start with that first ordered pair. Okay? Remember, ordered pairs are always in alphabetical order, so x is written first, y is written second. So that first ordered pair is telling you to let x be 0 and let y be 3. Plug those values into your equation. So that would give you 3 times 0 plus 7 times 3. And ask yourself, is that really true? Are those two sides equal if you let x be 0 and y be 3? Do the math. 3 times 0 is 0, plus 7 times 3 is 21. Is that equal to 21? Well, left-hand side, 0 plus 21 is 21. 21 equals 21. That works. Therefore, that first ordered pair, the answer is yes, it is a solution, because it gives you a true statement. All right, second ordered pair. We've got 7, 0. Again, for this ordered pair, we're letting x now be positive 7 and y be 0. Take your equation. 3x plus 7y equals 21, and substitute those values in for x and y. So we've got 3 times 7 plus 7 times 0 equals 21. That's our question. Are those two sides equal? 3 times 7 is 21, plus 7 times 0 is 0. Do the operation on the left-hand side. 21 plus 0 is 21. And yes, 21 equals 21. That's a true statement. So that second ordered pair also is a solution. All right, we have one more to test. Okay, this third ordered pair, we're going to let x be a positive 1 and y be a positive 2. Take your equation, put those values in. So we've got 3 times 1 plus 7 times 2. The question is, are those two sides equal? 3 times 1 is 3, plus 7 times 2 is 14. Is that equal to 21? Well, 3 plus 14 is 17. 17 is not equal to 21. And therefore, this ordered pair is not a solution to the given equation. So, if you are not given an ordered pair solution to test in the equation, how do you find solutions? Well, here's what we're going to do. If you're trying to find solutions for an equation and you're not given ordered pairs to test, then what we're going to do is, first of all, pick any value you want for one of the variables. So pick an x or pick a y. Second step, put this chosen value into the equation. Step 3, solve the equation for the other variable. You'll now have an x value and a y value. And your fourth step is check your solution in the original problem to make sure that it works. For example, find two solutions to the equation 3x minus y equals 9. Your first step, pick any value for x or y. You can pick anything you want. I choose to let x be equal to 4 for this example. So your second step is to take that value, 4, and put it in for the x variable in the equation. So now we have 3 times 4 minus y equals 9. Third step, solve the equation for y. So doing the multiplication on the left-hand side, we've got 12 minus y equals 9. Trying to solve for y, so we're going to subtract 12 from both sides. That's going to leave us with 0 minus y, or just negative y, is equal to 9 minus 12 is negative 3. And remember, that's an understood 1 in front of that y. So to get rid of that negative 1, we'll have to divide that out, both sides of the equation. And we find that y is equal to negative 3 divided by negative 1, which is a positive 3. Which means when, for this equation, when x equals 4, y equals 3, and in ordered pair notation, that would be 4, 3. To check our answer in the original problem, to make sure we didn't make a mistake, we've got 3x minus y is equal to 9. When we're checking, our question is, are those two really equal? So now we've got 3 times 4 minus 3, is that really 9? Which gives us 12 minus 3 equals 9. And if we do the math on the left-hand side, 12 minus 3 is 9. 9 equals 9. That's a true statement. Checks out, and it looks like our solution is fine. Okay, to find a second solution to the equation, 3x minus y equals 9, I have to pick another value. So this time I'm going to choose to let y be equal to negative 9. If we put negative 9 in for the y variable of the equation, we get 3x minus negative 9 equals 9. So now solve for x, so do the math. Notice here we have a double negative. Minus a negative is the same as adding a positive. So we've got 3x plus 9 is equal to 9. Solving for x, so subtract 9 from both sides. It's going to cancel out both on the left-hand side and the right-hand side. So now we have 3x plus 0 equals 0, or just 3x equals 0. Solve for x by dividing by 3. And here, x is equal to 0 divided by 3, which is simply 0. So that means x equals 0 when we let y be equal to negative 9 in this equation, or in ordered pair form, that's 0, negative 9. Now to check in the original problem, you're going to take the original problem before you did anything with it. We've got 3x minus y equals 9. We're going to let x be 0, and we're going to let y be negative 9. And our question is, since we're checking, is that really 9? 3 times 0 is 0. Minus a negative is the same as adding a positive, so we've got plus 9. Again, is that equal to 9? And 0 plus 9 is just 9. 9 equals 9. And it looks like that solution also checks out. Okay, so now let's say the problem asks the question like this. Complete the table for the equation y equals 1/2 times x plus 8. And they start the table for you. What they're doing here for you is they're telling you which first variable to pick and which to solve for. So we've got 4 points here to pick. We're going to start with that first one, where this problem is telling us to let x be equal to 0, solve for y. So take your equation, y equals 1/2. Now they're telling you to let x be 0, so we're going to put 0 in for x, plus 8. Now solve for y. Here we've got y equals anything times 0 is 0, plus 8. And 0 plus 8 is simply 8. So when x is 0, y is 8. We can put that into our table. All right? Next one. We're told to let y be 0 now. So taking the same equation, but now putting 0 in for the y variable, we've got 0 equals 1/2 times x plus 8. Okay, we're trying to solve for x, so let's clear fractions. Okay, we've got an equation, we've got a fraction, let's clear fractions. There's only one denominator there, and it's a 2. So if we multiply each and every term by 2, we should be able to cancel out all of the denominators. Remember, terms are separated by addition, subtraction, equal signs, and inequalities only. So this is all one term. You just need 1 2 there. You don't need 2 of them. Okay, remember that 2's in the numerator, so those are going to cross cancel. So you've got left to right, 2 times 0 is 0. That's equal to 1 times x, which is just x, plus 2 times 8 is 16. Now solve for x, subtract 16 from both sides. And we've got x equals 0 minus 16 is negative 16. So when y is 0, x is negative 16. Okay, let's now do the third item on the table. We'll let x be 2. So we've got y equals 1/2 times x, which is 2, plus 8. Remember that 2 is up in the numerator. So what's going to happen over here on the right-hand side is the 2's are going to cancel. Or if you take out a common factor, 2 divided by 2 is 1, 2 divided by 2 is 1. So now we have y equals, all of those are 1s, so 1 times 1 is 1, 1 divided by 1 is 1, so that's all 1, plus 8, and 1 plus 8 is, of course, 9. So when x is 2, y ends up being 9 for this particular equation. And we have one more. We're told to let y be negative 4. So if we come over here, we've got negative 4 for y is equal to 1/2 times x plus 8. Trying to solve for x. So again, we're going to clear fractions here. We're going to multiply everything by 2. So we've got 2 times negative 4 is equal to 2 times 1/2 x plus 2 times 8. As before, the 2's will cross cancel, leaving you with a bunch of 1's. So we've got 2 times negative 4 is negative 8. That's equal to 1 times x is x, plus 2 times 8 is 16. And solving for x, if we subtract 16 from both sides, we've got x is equal to negative 8, and negative 16 is negative 24. So when y is negative 4, x is negative 24. And this is the end of Module 8, Section 3.1 material. You should now complete the homework for Section 3.1 found in My Math Lab, and then after you've successfully completed the homework, proceed to the video for Module 8, Section 3.2.